Hello everyone and welcome to the second episode of Idiomatic Kotlin. This time we're going to take a look at collections versus sequences. Were you ever in a situation from the beginning that IntelliJ recommended you to use a sequence instead of a collection, and you wondered, what is even the difference and what are the implications if I would? Then this episode is for you. And even if you have a basic understanding of the two, we're going to take a look at the details today. We'll discuss why both of these exist in Kotlin, when to use which, and what are the pitfalls that you should know to improve your Kotlin code. For both types, we're going to look at real-world-esque examples to understand what the implications of each are. So let's get right into it. I don't have to say all that much about collections themselves, I presume. As a matter of fact, this video will be focusing on the specific differences between collections and sequences. I will not cover the Collections API itself. There's another video for that. Nevertheless, let's at least make sure that everyone is on the same page regarding the terminology before we jump into the details. When I say Kotlin Collections API, all I mean are the standard classes and extension functions that are shipped with an installation of Kotlin to collect a group of items into both mutable as well as immutable containers. As you probably know, the three general types of collections that Kotlin offers are lists, sets, and maps, as well as sequences, which we're going to look at today, even though a sequence is not a collection in the type hierarchy, but we're going to check that out in a moment. Now, the other important part of said API are all the many extension functions to process the above collection types. What I mean by that are things like filter, map, reduce, etc. I'm pretty sure you have used them before. If none of what I just explained makes any sense to you, make sure to first watch my introductory Kotlin course. If you are still uncertain, or I was about to lose you to outright falling asleep, let's get into the nitty-gritty details of today's episode, shall we? As you probably know, a collection is nothing else in its core but a generic group of elements of the same type. So, a list of int, for instance. As you'll see in a moment, that is what fundamentally connects collections and sequences. But that is already the major idea that they share. When I say collection, I'm specifically talking about the collection interface, of course, with its numerous implementations. What all of them share is that they implement the iterable interface, such that we can use them in a for loop. An important point to keep in mind once we move to sequences is that a collection always has a finite size at any given point in time. Of course, many collections can grow as long as the runtime can allocate more memory, but they still do always have a distinct size whenever we would check it, so whenever we would invoke .size, for instance. Finally, and that's the most important difference I will focus on today, they are eagerly evaluated when used with the aforementioned Kotlin standard library. What does eagerly evaluated even mean, though? Let's check out a nice graphical example that I prepared for you. So what we can see right here is how a collection, in the sense of the interface, so this would be a list, a set, a map, etc., and all of the subtypes of those, would be processed if you would use the Collections API on them. So what we do here, what I prepared for you, is that each of these circles with the numbers is one element. So what we just have is, in this case, integers. So we start with a list of size 10, and we just, to initialize it, take the index of each element as the value for it, which of course leaves us with a list which contains 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have this list of size 10, and that's our starting point. So here, first of all, you already see it's finite, of course. We can add further elements. We could add number 10, any other integer, but at every point where we check, it at least has a finite size, at the current point 10. What we then do is call .filter on it. In this case, it's not too important what we actually filter. In this case, we filter that the number has to be odd. So what we do then in this case is that we have to, and that's where the eager part comes into play, we have to go over every element in our list to check, is it odd, is it not odd? This would, of course, leave us with the next step in the third row, where we apply map. So what you can see here, firstly, is that we iterated through all of the elements in our list to filter, where we then arrived with the following list that now only contains a 1, a 3, a 5, a 7, and a 9, since, of course, those are the odd numbers under 10. What this means here is that at every processing step in between, so far we only had one, we iterate over everything in the collection and then create a new list with, or new collection with whatever is the outcome of this processing step. In the case of filtering, of course, well, not of course, but in our case, we filtered out some elements. So we went from a size 10 in this case now to half of that, a list of size 5 with 1, 3, 5, 7, and 9. Next, we do a mapping operation with this lambda here, which is just a square. So we do the number times itself. This, of course, means that we also have to go through every element. We do 1 times 1, 3 times 3, 5 times 5, etc. Which means that after this, we have another list that has, again, 5 elements, since, of course, we started only with 5. But a mapping operation, of course, never takes away or adds new elements. So we can be certain that afterwards we have another list of 5. Then the almost final step is the take. If you don't know what this is, so take, you can just supply an integer parameter to it. And what it will do, it will take elements out of the collection that you're processing up to this number, meaning that if it has more than what you're giving it, it drops everything that is more than the value you gave it, and if it has less, it will just get up until the point it can get. So in our case, we had 5 elements in our collection, and we say take 3, so we only take the first 3. In this case, of course, the function is clever enough that it can only iterate until the 3rd element, so we only get 1, 9, and 25, meaning that we don't even have to further iterate to 7 and 9, since we know we only needed 3, so there's no point in even looking further after we found our first 3. There's equivalent functions to, for example, start from the back or something, but take starts from the front. And finally, we call the toSet method, which would just put whatever we have right here, since we started with a list, into a set. In this case, this is not horribly useful, since it was already unique to begin with. But now we would have a resulting set with the values 1, 9, and 25. I hope this so far made sense. What is now interesting to look at, and you'll see in a moment why, is the way that we processed these elements. So you can, of course, see that I drew these lines with the arrowheads in between to show you how Kotlin internally would process this. So the important thing here to keep in mind, and this is what eagerly evaluating means, that we eagerly, so always go through the entire list at a time before going to the next step. So this is important to keep in mind, and that's just what this term means. So, for instance, if we do a filtering operation, we go through everything in the list first, filter out everything, and only then move on to map, which you, of course, see by the arrows and the lines. Everything is its own line, its own step. So we never continue with the following step until we completed the initial one. Now, one thing that's interesting to note here is how many processing steps are involved. Of course, this doesn't tell us much about the runtime speed or anything like that, or even the complexity, but it's still interesting to look at, which you'll see in a second why. So if you would count, in this case, all the bubbles in here, so each element that we iterate over, which in the beginning is a certain amount, and then for each step, sometimes more, sometimes less, we would arrive at 31 operation steps. You can count it if you want, or trust me. Just keep it in mind for now. It's not something that is horribly useful for now, but you'll see in a second why it becomes very useful. As I mentioned earlier, ultimately a Kotlin sequence behaves like a collection, while being closer related to how a stream works with Java 8. Don't worry if you're not familiar with that though. Just as earlier, when talking about a sequence, I'm talking about the generic sequence type that Kotlin ships with. Let's take a look at the differences, however. Compared to the collection interface, the sequence interface does not implement iterable. The main implication of this is that by default, we cannot just use it with a for loop. However, due to the Collections API, which by the way is called Collections API, even though it also supports the sequence type, we can nicely process sequences without needing a for loop. Furthermore, a sequence can have an infinite size. That might sound confusing, but in the following example, we're precisely going to see how that is possible. If you are familiar with generators in other programming languages, such as Python, this is a very similar concept to that. Finally, since you now know that a collection is evaluated eagerly, the sequence is the opposite. It is evaluated in a lazy fashion. Let's check out how the same example that we just saw would now look like with using a sequence. So right here, you see almost the same example we saw with the collections, since of course I want to point out the differences between the two. Where we started with the list constructor in the previous example, we now use generate sequence, which is a function that ships with the Kotlin Collections API, which you can give an initial value and then a lambda expression to generate an infinite or potentially infinite sequence of values based on this. What this would mean in this case is that we start with the value 0, and for each further value in a sequence that we want to evaluate, the Kotlin runtime would execute the lambda expression with the previous value to compute the new one. So in this case, of course, what this would mean is we start with 0, and then once we get to the first one, we would take 0 plus 1 to arrive at 1, and so on and so forth, which ultimately means that we have, again, a sequence of values starting from 0 all the way to 9. Something to note here, of course, is that a sequence also is generic with its type. So this would be a sequence of integer. But the other thing that is interesting to note here, and that's where the infinity part comes into play, this thing is theoretically infinite. That's what you see at the end there with the ... bubble, since, of course, by just doing this, and that's ultimately what a sequence or one major feature of a sequence that a collection cannot offer, when generating the sequence with this function, we do not specify anywhere what its size is going to be like. And that's where lazily evaluated comes into play. Because ultimately, and that's the most important thing here to remember, a sequence is only evaluated at the point, at the last possible point when it has to be evaluated. And that's where lazy comes from. So nothing is going to happen. It's lazy in its behavior until the very last moment when it has to. Yes, this might still sound a bit vague and abstract, so let's look at the example, and I'm sure then it makes a lot of sense. So what this mean in this case? As you can see, this is exactly the same example as the previous one, only with the difference, of course, that we start with a sequence. But ultimately, the processing is very different. So what happens in this case is if we have the same chain, though, with filter, if it's an odd value, then we do a square of that, and we take the first 3 and then we convert it to a set. That is, of course, the same. What happens in this case is that for each processing step, we only save, so to say, that we want to do that, but ultimately it's only executed once it has to. So what this would mean for processing of the sequence is that we start with our value with our value 0, and the first point where we actually need the value is in the take argument, right? So only once we hit take, like once the Kotlin runtime hits to execute take 3, then it would start evaluating to collect a first element to get closer to taking 3, right? So we start with the first one, or in this case, the value 0, and we generate it first of all with our generate sequence function, and we run it through our filter. In this case, we see, of course, it's not an odd value, such that we immediately throw it away and we don't even continue to mapping because it's filtered out already, right? This means since take still hasn't received anything, we have to go to the next one. So the control flow goes back to generating a next element in the sequence to further evaluate or to go again through the entire chain of filtering, mapping, and taking. So in this case, this would mean that we go now to value 1. We filter, it is indeed an odd value, so we can continue to mapping it to still 1. 1 times 1 is 1, of course. And now our take function is happy since it could take a first value. The final thing we do is to convert it to a set. What this means in this case is that we create a new set and save the first value into it. Then the control goes back to generating our next element. And now you can already see, I'm not going to go through the whole sequence since, of course, it's always the same. You can see how this works. We only generate a new element even once it's needed somewhere. So for example, if we would have said take 1 to set, the whole flow would have stopped after we found the first element. Of course, since in this case, we only take every second one due to the filtering, we sometimes have to generate a new value to only then immediately throw away again. But of course, we cannot know when generating, is it odd or not, right? But as you can see, the values are only generated when required. That's where the lazy term comes from. And we go, instead of going like horizontal left to right through everything. So we first generate the sequence, then we filter everything, then we map, which you saw with the collection. In this case, we do it step by step. So we only get a single element, then walk through the chain, which might mean that we can cancel it earlier than previously, since we already know after filtering this is no good. And only then we generate a new one, and we continue this until, in this case, we find our 3 elements. What you can see in this case now, which is very interesting, is that if you would count these together, these are only 21 operations. So this ultimately is one good reason when a sequence can be useful, which is that in certain cases, like this one, where we have some operations that can abort earlier, so that we have, in the end, less operations to do, we saved 10 operations in this case. So remember on the previous slide, we had 31 operations for a collection, and this is exactly the same for a sequence, and it even supports theoretically infinite sequence, and we saved an entire 10 operations. Of course, this effect gets less and less the more we would need. So if we would now say, I don't know, take 5, we need a lot more operations and get very close to the amount of operations we would need with the collection, since ultimately then we have to go through everything. But you can see for this case, it makes quite a huge difference. Of course, keep in mind that this is not, as I said, evaluating the runtime. So this is really just counting the bubbles. This is a quite primitive way of doing it. But to showcase what happens under the hood, this is perfect and something to always keep in mind. Now you know what both the collection as well as the sequence are in Kotlin. However, we haven't covered yet when to use which, apart from the obvious reasons, such that your input is potentially infinite. Thus, I prepared some real-world-esque examples to show you when to use which and why. As always, all examples are available on a public repository on GitHub as a branch as well as a tag. You can find the link in the description under this video. But now, let's get going. Welcome to the example right here. I prepared for you a developer notification service, which is, if you watched the first episode of Idiomatic Kotlin, very similar to what we did there. So we want to notify our developers by email. In this case, this is not entirely close to real-world code for the simple reason that I added some extra things in here that we will need to see what the difference between collections and sequences are. But if you would imagine that everywhere where I used the scope functions right here, by the way, if you don't know what that is, make sure to watch the first episode. If we would leave them out, the code would be real-world-esque again, I would argue. So let's quickly go over what we're working here with. We have a developer repository, which we receive here in the constructor, which is just, database access. So what we can do with this in this case here is we can find developers by their type. So we have the developer object right here, which has an ID, a name, a type, an email address, and a nullable assignment. All the rest here is not horribly important, but that's just nice that you have seen it. Let's quickly look at the developer type, which is for now only front-end and back-end, so it's an enum. Yes, and what we do in this case here is we want to notify our developers by email. We receive a developer type as well as the notification we want to send via email. So what we do at first is we get all the developers that we have in the database with this developer type into this set. And now we're going to use some of the Kotlin Collections API. So what we do in this case is we filter out all the developer that do not yet have an assignment. So this is filter not, which is the same as filter with a negation right here. So we say if the dev is assigned to something, we filter them out. So that's how this would work. So after this first step, we only have people that do not have an assignment currently in the database already. Next step is that we create the email objects that we want to send. So right here, you can see this extends like a common service that we can also quickly take a peek at. So there's a generate email function that is protected, so the implementations can call it. And you know this example from the first episode. Maybe we generate an email with the recipients, so the email address of the developer and some other stuff here. Of course, notification is converted into the subject and the email body. And finally, we return this message object, which is from the JavaX mail library, which we can then send as an email. Yes, let's go back here. So we generate the emails by passing in the developers and a notification. And now, of course, we end up with all these message objects. Now we decided right here, this is a pretty arbitrary decision, but we'll refactor it in a moment, that we only take the first two. The idea here really is that we want to make sure that at least two of the developers right here are notified, such as that if one doesn't see the email or whatever, at least there's one fallback person that hopefully does see it. And finally, what we do is we take each of our email or message objects and we send the email. That's ultimately already all the code. So we have the filtering, mapping, taking, and then the for each step to do some action, in this case, sending the email. As you can see now here, at each of these steps, I'm logging some small thing to see what happens under the hood. And I'm going to run this code right now, actually, to together with you take a look at what would happen in this case. So what I prepared is that I generated a set of random developers with some random names as well and random email addresses. And we're going to run them through this chain right here to see what would happen. So let's do just that. Yes. So this I did this as a test, such that I can mock some things, but that's not horribly important. Let's look at the output. So we start with some developers. These are just some developers. As I said, it's randomly generated, and the true false here implies if they have an assignment or they do not have an assignment. So we have true false, true false, true true, false false. Let's now see what happens with the collections. So all I'm doing here is I'm calling this method with the developer type backend and a notification that contains some example. So what we can see now right here is, and that's of course where this integer was used for, we're counting, just as you saw previously on the slide, we're counting how many operations we're needing. So we're starting right here, and you see at each step I'm logging if it's a filtering, a mapping, or sending email operation. So we start here with a first operation where we filter the first person here, and as you can see, as you saw on the slide, we go through it one by one. So we first filter each of these people, so 8 here in total, such that all the ones that have a true right here, so that already have an assignment, we're filtering them out. Nevertheless, of course, that's why it's logged right here. We still have to, we have to evaluate them during the filtering step. That's why here it says filtered. Because before evaluating that, we cannot know if we're gonna throw them away out of our chain or not. The next thing that we do then is that we map. In this case, you see, of course, we only have 4 people left, since if you peek here at the beginning, we had false, 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 and false. So Mickey, Wilfred, Caitlin, and Cruz, they don't have an assignment. So we take, these are the 4 that are left over after our filtering. So for these, we create an email object. So that's why we map right here. And as a matter of fact, you can see that everything here is false now. Almost finally now we take the first 2. So take always takes from the beginning. So we would only take Mickey and Wilfried, since these are the first 2 obviously. And finally we're sending an email to them too. In total, you can see this took us 14 steps, which is not particularly good or bad, but it's just something to keep in mind. If we now look at another way how to do it. So what we can do as well is, if we look at all the implementations of this, we can see that there's also a sequences developer notification service. So right now, or earlier, we had the collections version. As you can see, this is exactly the same, with the small difference that at the beginning right here, we say as sequence. So we're still starting from a set, and what as sequence ultimately is just doing, of course, is that it converts any iterable, such as a set, into a sequence of the same generic type. So what we have after this step is a sequence of developer. Let's scroll down a bit here, because what we have right here is the same output run through this method with the sequences. And you can see precisely what we saw on the slide, but a bit more graphical right now, which is that because this is evaluated lazily, where you saw right here with the collections that we evaluated them eagerly, meaning that we first do every step proactively, so to say, without knowing are we ever going to need the object or not. And this is ultimately what you should realize. This is really the most important thing about eager evaluation versus lazy evaluation. If you, for instance, look at, here, Sherilyn, we're going to run her through the whole filtering step, right? Even though at the very end, we're not ever sending an email to Sherilyn. So this is kind of useless. You could argue that we are evaluating Sherilyn for filtering, since we're not going to use it later on. Even more interestingly, if you look, for example, at Caitlin, we filter them and map her, even though we also don't send an email at the end. So this is what is ultimately the difference when using a sequence. So what happens right here is that we start from the beginning as well and first filter Oina, which was true. So we take her out since we're only interested in the false people right here. Then we go to Mickey. We see he's false. So we continue with him. We map an email to him and we send the email. And now you see ultimately what you saw on the slide with, instead of going left to right and doing filtering, mapping, etc., we go up and down, so to say. So we first filter one person, then we map if necessary, and so on. So what we can see in here is that we now already sent the email to Mickey, since we have specified that we need 2 people, such that the first person is now through there, which means that we can continue with the next one. This is Sherilyn. She's true, however, so we filter out, go to Wilfried, and do the same here. We're mapping since he's false, and finally send the email to Wilfried. Now you can see the big difference again, and this took us 8 operation steps, whereas this was 14. So we saved almost 50% of our operations by using a sequence right here. Now you might say, yeah, Jacob, then why are we not always using sequences? It's clearly like faster. That's not entirely true, and that's precisely why, by default, Kotlin is usually using regular collections. The important thing here to keep in mind, which I can not show you very easily, there is ways, of course, but not in a very easy fashion at least, that with using this as sequence right here, or even if, let's say, this would already return as a sequence of developer, there is an overhead involved in terms of computation. So doing or creating a sequence, a lazy sequence out of something that is a regular collection comes with a slight overhead in terms of creating it and iterating over it, etc. Meaning that the effect here of having less operating steps is not the whole picture. You should always also keep in mind that this makes, or let's say the effect is greater with the more steps you have to do. So in this case right here, if we would evaluate this with proper profiling, so to really see how much computational time this needs, we would likely see that the difference is not really existent in terms of the raw time, not just the steps, or even that the collection performs better than the sequence because of this overhead involved. So where the general first takeaway right here is that when you have either very many steps involved, right, or you have very many objects involved that you have to process, the effect of using a sequence becomes better and better with that. So if you have 50 steps right here due to this effect of only doing one by one, the sequence is better and better with more steps. And furthermore, if we would have to do this instead of with just 8 developers with 1,000 or something, this would also be quite a lot better probably, since you see clearly the difference that this would have. Of course, it also depends on the structure of this. So let's say all of our true people are at the beginning for whatever reason. So the first half of the 1,000 is only true people and the second half is only false people. Of course, then the effect is also minimal since we anyways have to go through all the true people to figure out, oh, they were true. I cannot create an email for them. In which case the collection would perform just as good. So it also depends a bit on the structure of the objects. Of the collection or sequence. The next thing to keep in mind is if they are short-circuiting operations or stateful or stateless operations. This might sound a bit weird, so I'm going to explain, of course, what that means. So there's certain operations in this chain that for sequences do not require any state. a good example of this is filtering or mapping. Of course, we can evaluate each object by itself. If we want to filter if here cruise at example.com has an assignment or not, we do not care what comes before and after cruise. We just care for the object itself, right? That makes sense. So this would be considered a stateless operation, since we do not require any state from our entire sequence to do anything about it. A stateful operation, on the other hand, would be something such as sorting. So if you would filter out the people that do not have an assignment and then sort them lexicographically to have the sorted by their email address here, then of course this is a stateful operation, since you do have to then first get all the people. Essentially what happens under the hood is converted into a collection, actually, do your sorting, and then continue with the sequence. Since of course, if you do it this way and you only look at one person at a time, you cannot know, like, is later on going to be someone that starts with a Z or with an A? You only know that once evaluating everyone. So this would be considered a stateful operation. The other thing to keep in mind is if it's a short-circuiting or terminal operation. Short-circuiting just means, can I abort my processing at an earlier point in time before going through everything? You saw it already earlier in the slide. Here, the best example for this is the take operation, of course. The reason you see very clearly in here, this short circuits in the sense that we can stop processing once we found 2 people. Whereas in this case, we first filter through every 8 persons, only to then map and to then send the emails. Whereas here, of course, after we sent the second one, we know, hey, we only needed 2 ever, so no need to continue. So this is what short-circuiting refers to. What you'll also sometimes hear is a terminal operation. What this just refers to is that at which point you have to collect your elements. So if we look again at sorting, or for instance, if here I would say to list at the end, right? This is something that is terminal, in the sense that up until this point I can evaluate lazily, but here I have to get everything that I had at this point in my sequence, and create a list from it. So it interrupts the sequence, and as a matter of fact, it of course returns a collection. And you can even see here, if I'm hovering over this, it says the operation is terminal. So what this just tells you is that it collects together your sequence into a non-sequence collection, such that at this point in time you would lose the effects of the sequence. This would of course mean that now if here, let's say I do to list and then here I continue filtering, this next filtering step is again eagerly evaluated, since this was a terminal operation. The final thing we have to quickly look at is intermediate operations. So if I here say sorted by, let's say the email address, as we said, we could say it dot, or let's say that or here first recipient, so the email address. So if we look at the kdoc here of sorted by, we can see in the last line right here, the operation is intermediate and stateful. So all that this means is that, of course, stateful we already discussed. We have to evaluate each element in our sequence to be able to sort it. Otherwise, we don't know, okay, is there someone going to come that actually needs to be further in our sequence or not? But intermediate at the same time means that it still behaves lazily up until this point. So what this just means is that usually, of course, if you would sort a collection, which works just fine as well, of course, you would do each step until there eagerly. So you would first filter, then map, etc., and then sort. Whereas if you call sorted by on a sequence, the sorting step itself is stateful, such that it has to collect every element in the collection, then sort, and then return a new sequence. But what happens beforehand stays lazy, and that's the point. So this sorted by will only like start sorting once it has to. That's what the intermediate refers to. So it still behaves lazy, and also it will return a new sequence. Of course, though, keep in mind for this one that this means that it doesn't, that the whole, like the processing of this step itself is still stateful, right? So you you will lose this effect of I filter one person, I map one person, and so on. You will have to get everyone and then sort them, and you can continue. So this is something to be very careful about, and I can only recommend to always read the KDoc of all of these operation steps to see are they intermediate, stateful, terminal, etc. Now let's check out some of the pitfalls of sequences, since for now, as you can see, and I mean, I gave you already something to be cautious about, but still on paper, it looks very tempting to only always use sequences, since in many cases, actually, it will result in less operating steps. But let's check out a quick thing. So we now realize that here saying take 2 is a bit stupid, since first of all, this is just like a magic number. And secondly, the chance that if we take the first 2 developers, that none of them is going to read our email, our notification email, is still pretty high. So instead, what we want to do now is that, of course, we want to send it to more people. In this case, we decide we want to send it to half of the people, of the developers. So the first thing, of course, that you might do here, and this is of course dangerous, but we can still do it. We take the count of the developers divided by 2, so 50%. Now you might notice or not notice that this, of course, can be pretty dangerous, since this is based on the initial set of the developers, which contains everyone not filtered out. So in this case, we would, we're not going to take 50% likely, but more people, since we filtered out quite a lot of them. So what actually we want to do in this case is that we want to take half of the count of the developers after our filtering step, right? This is ultimately what we're interested in. So what we're going to do right here to do that is put this into a variable. So we're going to call this filtered developers, or we can also, this is actually a bit of a stupid name, unassigned developers is way more descriptive. As you can see right here, this is still a sequence of developer, meaning that actually, since this is not a terminal step, like writing this and executing it does literally nothing, because there's no reason for, and this is where the lazy aspect again, I want to make sure of that you understood it. There's no reason for Kotlin to do anything, since there's nothing to do with this. So if you would imagine that this stuff wouldn't be here, this piece of code would not execute anything. Of course, we would generate a sequence, but then we don't even start filtering, since there's nothing that is terminal about doing something with the filtering. So what we can then do right here is that instead of saying of content developers, we count the unassigned developers, right? That seems quite good on paper, I would argue. So let's execute this. And then you'll quickly see one of the first pitfalls, which you might have already guessed after what I explained earlier. Of course, we didn't change anything about our collections, so let's scroll right to the bottom. And now you can already see, oh my god, what the hell happened here? We went from 8 processing steps to 16, and now this should ring the alarm bells, since if we check here for the collections, we actually have 2 more now all of a sudden, where we had 2 less beforehand. And there's no clear indication right here, like why this happened, right? You might guess it now already, and of course I'm going to explain it now. But it's not that anything warns us here or that it's super obvious where this came from. Of course, the culprit right here is the fact that count is a terminal operation, right? If we would hover over it, it also says that operation is terminal. And that's again where I can just stress, always read the KDocs of the Collections API in Kotlin, since they're very helpful. You can see it's short text, and they always mention if it's terminal or stateful or stateless or whatever. What happens here, of course, is that we, as I said, until this point, do exactly nothing, since there's no terminal operation. Then we, again, technically speaking, don't do anything here. And the first time we would do something is for taking, right? Because there we have to, we have to execute until we have the amount of people we specified right here. Problem though is that the count is terminal, meaning that once it hits this part here where the value is, hey, how many people should I actually take? It sees count how many unassigned developers there are. And since I mentioned, of course, that this didn't even run yet, what happens, and this is precisely what you can see in the logs right here, it filters, or it iterates over all of the developers to figure out, hey, who are actually the ones that we filtered out, right? So as you can see right here now, the first steps right here are just the first 8 steps are just filtering out all the people to figure out, oh, it's 8. That no, sorry, the filtered out, of course, are less, but we have to iterate over everyone since we have to filter out, is it true or false? So the filter out at the end are 4 people, of course, which now we can take half of, which, funnily enough, again accounts to 2, but that's just a detail at the side. Since this happened, you can now see what happens next. So until this step right here, the number 8, this is all just to get the count of how many are filtered out, in this case 4. And what happens next is that we actually start our processing of the sequence. And then only starting from step 9 onward actually is our sequence processing. So you can see here Nona at example.com actually is filtered out again, since now we start our processing. It will just do that again, since the sequence is lazy, as you know, so it only does something when it's told to in the last moment it has. This is precisely the last moment when it has, because we want to take, in this case again, 2 developers to send them the email. So what it does, it starts again from the beginning and now knows, well, I need 2, so let's get going. So it filters again the person that already did earlier, just to get the count. In this case, filters her out, or him, not sure, Nona. Next, we're Jeffrey, we leave him in the collection, or in the sequence in this case, because it's false, and send an email, and the same here again. In the end, it amounts to sending Jeffrey an email and Eldon an email. With the negative side effect that we took 16 operational steps to do that. This is, of course, definitely worse. If you now also consider the overhead that I mentioned, this is certainly worse than just doing it straight up with a collection, the other way around. We can actually check out what the collection would have looked like if we do the same. So if we would do the same right here for our collections version, unassigned developers, and we change this here to unassigned developers.count divided by 2. So we take half of what's left here and we execute that again. You will see that this actually made no difference whatsoever. We still have 14 processing steps. The reason being, of course, that since this is evaluated eagerly, it makes no difference in which order, so to say, the order makes a difference, but it makes no difference that we do it in 2 separate steps. So we eagerly get first filter through everyone and even create a new variable with this new list of developers. So this will only contain everyone that had false right here, meaning that later on, when we have to count how many were in this list, it's a simple operation, as you would know it from any language, where you just say, yeah, how many elements does this list have? Nothing fancy, right? So this, of course, adds a step in evaluating the size, but it doesn't have to do any extra processing. And this means, of course, that we first filter everyone, and then later knowing that we needed 2 people is just a matter of checking how large this list was. And as you can see, this still results in exactly 14 steps. So the first pitfall to keep in mind when using a sequence is that, to always check, am I using terminal operations or where are they if I'm using some, which, as I said, the kdocs here are perfect for. Of course, I use this count here on purpose since, as you might have guessed, a sequence does not have a size size property. Instead, what count does, if we would check it out, is actually it just literally iterates over everything, and counts it, which is precisely the reason, of course, why we see this behavior right here of filtering everything once and then another time again. If you keep this pitfall in mind, that's already pretty good. However, there's one other important one that you will get with using sequences that you should also definitely know about. And this is the following one. If you, at the end of your operation, for whatever reason, cannot do something like this, where you say for each, which of course is nicely usable in a lazy way, since it only it only has to do your operation, in this case sending an email, once you reach the step, which is precisely what you can see here, of course, that we send an email and then only continue with the next step. If you cannot do this, but instead you have to collect into let's say into a list, for example. So we would, in this case, get this right here and say emails, and then do this here. I know this doesn't make any sense. There's no reason you would do this, since you can just do for each. But let's say there would be some reason that we would need the emails in a variable to do something with them, and only later on we can send them. I'm sure you could imagine some scenarios where this is just required because you need the variable for something else. This can also be pretty dangerous. And what I'm not talking about in this case is that this is terminal. If you hover over it again, you see the operation is terminal. Of course, this would also not, you wouldn't benefit a lot from the sequence, since anyways at the end you have to collect. Of course, you might save some extra steps, so it's not entirely useless to do this, but just this is something to keep in mind. But it's in this case not the pitfall I'm talking about. The pitfall is something else. So how this will work, and we saw it quickly on the slide with the sequences earlier, is collecting into this list, and as a matter of fact, let's just check it out actually, would work in a way that, let's click through this, would work in this way. So we create an empty array list in this case, or a resizable list. And what we can just do is that we iterate over each element and just call add on our array list here and add each item. So for our sequence, we would just go over each element in the list and in the sequence, and would add it to a new list, and then at the end we return this array list such that we have it. And the problem precisely lies, or I have to say, lies in this step. So if you compare this to how it works with the collection, let's quickly check that out as well. You might see already what the problem is here. So if we go to the collection again, and we do the same thing here. So let's put this into a variable, say emails. In this case, of course, we do not need to list, since it's already a list, but let's do it anyhow. It doesn't have any effect, but you'll see what happens in this case. So what happens right here is that there's a few other things done to optimize this, but if our list has a size that's anything else but a 1 or 0, we just call to mutable list. And here's the big difference. What happens right here is that we create a new array list and pass in our other collection that we want to convert into a list. So let's say we started with a set, for instance. This would give it a set, but the constructor of the array list just accepts any collection, so sets just as well, or anything else that implements collection. And what you don't see here is that it creates an array list of the size of the collections, and of course you can easily know the size of the collection. And then just creates a new array list with the size and stuffs everything in there. The difference is that if you do it like this, the size is known beforehand, right? And this is ultimately, again, where the laziness and the eagerness comes in play. Because this is the collection is always evaluated eagerly, the array list constructor can just call this .size, and it can know, hey, okay, this is size 5, size 1,000, I don't know. But at least it's known. Of course, with a sequence, if it's infinite, of course this won't work. But even if it's not infinite, as in our example, it can only know the size by iterating through everything. And this is precisely, of course, what we saw in the other example right here, where this is calling .add all the time. So at the creation time of the array list, actually right here, we created with nothing. And this is a detail in this case of how it would work if running on the JVM. This might differ if you run Kotlin on another platform, but an underlying JVM array list is created by default with a capacity of 10. So what this means is that if you do this, just create a new array list with nothing yet, like empty, it internally allocates an array. That's of course where the name array list comes from, with a standard capacity of 10. This is just like an estimation to have, because you have to, of course, have some memory block allocated somewhere to then add your elements. And 10 is just like, yeah, a good standard, let's say. Like most lists are around this size that the Java devs determined. So let's start with that. What happens under the hood, however, is, of course, this is known for being resizable. So if you want to add later on an 11th element, what just happens is it takes the entire array and copies it into a new array that is 50% larger as the previous one. So you would start with an array of size 10, and once you add the 11th element, it copies it into a new array, allocates new memory with 15 capacity, and can add the 11th one. And it does that over and over, always increasing by 50% size once it has to. And this is, you might already imagine now, why this can become problematic when using a sequence. If not, let's check it out. So what we can do, or what I did here for you to make this one clear, is I created a collection that logs for us whenever it adds an element or it resizes. So what we're going to use right here is not the to list, but I created a separate extension function to spy collection. What is a spy collection? I just created this myself, and it's just a mutable collection that first of all logs when it was initiated, and also it logs with how many things it was initiated. You'll see in a second how that is interesting. And then each time we have to increase the capacity internally, we log that this happened. And also we log every time that we add an element. So it's just a regular array list actually that logs whenever it does some action. Of course, do not use this in production. This is a horrible implementation, but it's just good to see how this would work. So if we do this right here, and as a matter of fact, we also have to do it, of course, for our collections to be on the same page here. If we do that and execute, you'll see the following effect, and this is something to be very careful with when using sequences. All right, what we see right here is that for our regular collections, so in this case we start with a list, right? And we just converted it to this custom spy collection, which in essence does nothing else but putting it in a new list object. It's really nothing fancy. What we see right here is we do our general stuff, and then right here the spy collection logs that it was instantiated with 2 elements. This makes sense, of course, since we said here take half of that, which was 2. So here comes into play what you saw in the regular toList extension function. That of course we know already at this point. Hey, we have 2 of size, so we can just add we can just create a new spy collection with 2 elements. And you see that also we never add anything new, since of course we know at the beginning it's 2, and that's it. There's no reason to add anything. Of course we can later on, but when calling this conversion, we initiate it with 2 elements, and that's it. And then finally in the for each here on our new spy collection with the messages, we send the emails. If we, however, go over to the sequences side, we can see a bit of a different story. So what we see right here, apart from what we already discussed, that is a bit ugly, or not a bit ugly, which is not nice, of all this filtering, we also see that we initiate our spy collection with 0 elements. And this, of course, stems from the same fact that you saw right first. We create an empty collection, and then for each, we continue evaluating lazily, such that for each time we actually have to add something here, so we reach the step with something that we took, we then call .add to add it. And you see precisely this. We say here Java X email, yeah, it's just, it doesn't have a proper toString method, but you see we added a email message. We continue lazily filtering, and the next time we have a second person, we add another one. And now we have 2, which we needed, so we can continue with the for each and send. This in itself is not horrible. Of course, it also involves more steps, like I'm not logging here the number, but of course you can count them. That is, of course, something to also already keep in mind. We have to call add all the time for each element. In this case, the effect is very minimal because you only have 2. But this is something that is potentially problematic. However, now let's do one thing, and then you'll see why this actually, is as can be even more problematic. So if we check out the test that I wrote, and it's not really important what is in here, if you're interested, check it out in the Git repository. What I'm going to do right here is that instead of using our 8 people, so this is just the assigned statuses of them. So if we would change this right here, instead of having hard-coded 8 developers, so to say, to let's now say we have 100, and we just initialize these assigned statuses with a random Boolean, since I don't want to write true, false 100 times, obviously, right now. So this is an entirely realistic scenario, I would argue, and it just emulates our database, giving us more developers back for our query. Of course, we can guesstimate at the time of writing, but we can never truly know, hey, will the database return us 5 developers or 1,000, right? That is something we very seldom know when writing the code. So this is a realistic scenario. If we now would go back and execute this again, we can see the pitfall in full effect. So the first thing you will notice, of course, is that we have a lot more developers right here. As a matter of fact, 100. And the other thing, we see that for the collection, we do what we always did. We first filter everyone, and then we map everything into the email messages. And finally, in this case, we instantiate our spy collection with 26. So apparently here, half of the filtered ones were 26. Of course, this differs every time a bit since we're having randomly generated data in this case. But in any case, we instantiated this with 26, and then we send all of our emails. For the collection, for the sequence, we also do our unnecessary filtering, as we already said. We could now get rid of it, but let's ignore it for now. But again, we instantiated with 0 elements, and instead, lazily, each time we have a new one, we keep adding it. So we add a message and add more messages over time. And now you precisely see where the problem comes in. At this point, we apparently added the 14th message, and now we want to add a 15th, the 10th message, and we want to add an 11th one. So remember, the default capacity is 10. So at this point right here, before being able to add a new one, we have to increase by 50% to 15. Which means, of course, that it copies the array into a new one, and then it's able to add another one. And now you can already see what the problem here is. Next time we say, only shortly after, like we only added, well, a few more, we again have to copy the entire array into a new one and keep doing the same. And we do the same right here. And finally this stopped. And we eventually have our spy collection in this case, and we can send all of our emails with the 4 each. And this is something that is very problematic. The adding here at each step is already not very nice, but that's not horrible in terms of the runtime. This, however, for both run as well as space complexity is pretty horrible. Runtime-wise, copying is a pretty heavy step. We have to allocate new memory, copy everything over. Of course, this only takes a few milliseconds, but in the grand scheme of things, it's quite a heavy operation. And for your space is also not good, since you always have to allocate new memory, garbage collect the old one, and and you see the speed at which this is happening. So if we would check out here the timestamps, we create a new one here at 335 milliseconds, and in the same second still, only 4 milliseconds later, we do the same again. We throw away all we had previously and garbage collected, or well, we first copy and then garbage collect, of course, to get a larger underlying array list, or array rather. And this is something to be very careful with. So if you do this on a collection, not specifically spy collection, of course, since you should never use that. But here to list, to a set or any other collection, a map also fine. Be aware that with increasing size of your input, this is a problem that will likely happen. Well, actually, you can estimate it very easily. At least for array list, as I said, the default is 10. So if you can, for whatever reason, can estimate, or at least make an educated guess, I'm going to have more than 10 in my resulting list, then this is something to be very careful with. Of course, if this happens once or so, it's not horrible. And anyways, it's not going to make your code grind to a halt. but it's an effect that you likely want to avoid. So yeah, these are the two pitfalls that you should keep in mind when using sequences. That's it. I hope that I made it really clear to you what to look out for when using the Kotlin Collections API. I hope you got something out of this video, specifically when it comes to the examples that I prepared for you. Thus, I would recommend you to check out those examples again if anything isn't entirely clear yet. You can of course also leave a comment below. I'm always happy to help. Let's now summarize again what the important reasons are to choose between when using a collection or a sequence. Firstly, think about how many processing steps there are. The more you have, the more likely it typically becomes that you'll benefit from a sequence. Specifically, if you filter items out, as they do not have to be collected into intermediate collections all the time. If an operation can short-circuit, such as first or the take we saw in the example, a sequence is oftentimes better, as you will typically save many operations that would have happened with a collection. However, always consider the overhead that sequences bring. It's hard to estimate, but keep it in mind. If your input is not very large and/or not many processing steps are involved, it usually does not improve the performance to use a sequence. Stick to a regular collection in that case. If you anyhow have to collect into a collection as the last step, with the toList, toSet, etc., consider using run from the get-go. As you saw, the constant resizing of the collection certainly has adverse effects. The most important thing to consider, in my opinion, is if an operation is terminal or stateful or not. If you specifically use a sequence only to sort it later, which of course means that the Kotlin runtime has to evaluate the entire sequence before being able to continue, it oftentimes makes no sense to use a sequence from the beginning. Don't forget that in that case, the kdocs are your best friend, as they always specify this information. Finally, by default, you should stick to a good old collection. However, always consider the considerations we discussed to quickly assess if a sequence potentially makes sense or not. If in doubt, the only thing you can really do is evaluate it with a proper profiler to figure out what the raw runtime difference is. But of course, this is quite tedious, so in many cases I can recommend just making an educated guess, and I hope I gave you some pointers how to do that. And finally, I can of course only recommend that you try the collections and sequences out for yourself if you haven't done so already. Keep the pitfalls that I discussed in mind, and you'll be a master of the Kotlin Collections API in no time. Let me know in the comments when you are using collections or sequences, and if you have a nice other heuristic to decide when to use which. Apart from that, if you enjoyed this video, make sure to leave a like under it, consider subscribing to the channel for many more videos like this one, and share it with other people that might be interested. Finally, all that's left to say from me is, see you next time when we look at more idiomatic Kotlin. Tschüss!